Enthalpy of formation, which is often written as delta H subscript F. It's the enthalpy of a reaction when 1 mole of a substance is formed from the elements in their standard states. And the standard states are their of an element is their states under normal conditions, which is typically set at 1 atmosphere. So here we have some common standard states for many of the different types of elements. Most metals are monatomic solids, the one exception being mercury, which is a liquid under normal conditions. The 7 diatomic elements that you're familiar with, most of those are gases, except bromine and iodine, which is a liquid and solid, respectively. Okay, 3 other common elements: carbon, phosphorus, and sulfur. They exist as different allotropes or in different forms. And so the standard states for these 3 elements is the graphite form of copper, white phosphorus, and the rhombic form of sulfur. And notice phosphorus is P4. So for example, if you form carbon dioxide from its standard states, you would take oxygen and the graphite form of carbon, and the enthalpy of this reaction would be negative 393.5 kilojoules with respect to the stoichiometry of the equation. So the enthalpy of formation of CO2 is said to be negative 393.5 kilojoules per mole, because again it's specific for 1 mole of that substance. So in the back of most textbooks, or Gen Chem textbooks, there's usually one big table that has a lot of elements and the enthalpies of formations. So somewhere in here there's carbon dioxide, and if you can read it, you can see it is given as negative 393.5. And if you notice, a lot of these that we said were standard states, like chlorine and bromine, and graphite's in here somewhere, there's graphite. These are all set to 0. And that's the normal convention. All of these standard states have an enthalpy of formation equal to 0. So for any other reaction that isn't a formation reaction, you can get the enthalpy change for that reaction by taking the sum of the enthalpy formation of the products. That's sigma in math is often used to represent sum, minus the sum of the enthalpy of formation of the reactants. So for example, let's look at the combustion of sugar. If you look in your table of enthalpies of formation, sugar will be negative 1268. Oxygen, again standard state, is 0. CO2, like we said, is negative 393.5, and liquid water is negative 285.8. So again, it's just the sum of the reactants, or sum of the products minus the sum of the reactants. But you got to pay attention to the stoichiometry. For example, with CO2, it's negative 393.5 kilojoules per mole. But there are 6 moles shown in this equation. So essentially, whatever the enthalpy of formation is, you're going to multiply that by the coefficient shown in the equation. So again, you take that, you add up the product side, which for water would be 6 times negative 285.8 minus the sum on the reactant side. So it'd be 1 times negative 1268 plus 6 times 0. And that gives you negative 2808 kilojoules. And it works out to be in kilojoules because for each of these, the mole unit's going to drop out. So that's pretty much it. These, like I said, the enthalpies of formation are given in the back of the book. The one thing you got to remember is you got to take these and multiply it by its coefficient.